This video is over solving using inequalities. An inequality is just like an equation. The only difference is you have a symbol at the end that's not equals. This is less than or equal to because this extra line. Greater than or equal to, again, because of this extra line. The first example that's on your screen is a story problem. And what we're going to do is write an inequality, and then we're going to solve it once we get it set up. When she babysits, Ariel charges a fee of $1.50 for each babysitting job plus $9.50 for each hour she worked. Ariel only accepts jobs if she earns at least $30 for babysitting. Write and solve an inequality to determine the number of jobs she will accept. And then it says create a graph to represent the set of solutions. And when it says create a graph, that just means a number line. If you go back and look at the problem, the important things that we need are, there's a fee of $1.50. That means it's only going to happen one time. So I'm going to go ahead and write plus $1.50. Then as you keep going through, it says plus. And the other number that's there is $9.50 for each hour. Before in my videos, I've talked about when it says each or every, that means that's a signal for the number that gets a variable. So I'm going to put $9.50 X because we don't know how many hours she's going to work. The last thing when you keep reading is she earns at least $30. At least means you could get more, but you cannot get less than. So she can get more or exactly equal to, but she cannot get less when it says at least. So now what I'm going to do is I'm going to take the numbers that we said were important, put them together, and then solve it like a normal equation. $9.50 X plus the $1.50 fee is greater than or equal to $30. And again, when you solve this, it's just like a normal equation. When I solve it, I draw a line down the symbol, and then I start working backwards. So the opposite of adding $1.50 is subtracting the $1.50 of the fee. 30 is not a decimal, so I need to make sure and line up decimals when you get ready to subtract or add. If I have a $30 and I take away $1.50, if you need to borrow this, you can. If not, it should be $28.50. Then these numbers cancel each other out. I'm going to take this $9.50 right here, and I'm going to bring it down underneath. $9.50x is greater than or equal to $28.50. If you go ahead and divide that out, or if you think about it and estimate, 9 can work with 28 about 3 times. I divided it on a piece of paper and it was exactly 3. So I'm not going to take up space on the screen. I'm just going to say x is greater than or equal to 3. So the answer for this, the final answer would be 3 hours or more is how much she would have to work. 3 hours or more. The last thing that the question said was create a graph to represent the solution set, because whenever you have an inequality sign, there's more than one answer that fits to make it true. So on a number line, what this would look like is, I know the number itself is supposed to start with 3. I'm going to put a 3 on a number line. This extra underneath the greater than sign means also equal to. So on a number line, that would have a circle and it would be colored in. If I draw the circle and then I shade it in, because the answer could also be equal to 3, And then greater than means everything to the right of where the dot is. If the answer choices were number lines, that's what I would be looking for to pick the right one. I know the dot has to be on 3 because when I solved the question, I got 3. The dot needs to be on 3. And then this extra line underneath it means the dot needs to be closed. So those are the super important things you need to look at. The last video, or the last story problem on this video, says Byron took the subway to do some errands. He paid $2.50 each time he got on the subway. He spent $7.50 for lunch. He knows that he spent less than $20. How many times could he have ridden the subway? Starting back with what is the important information when you look at the story, it says he paid $2.50 each time. Again, when you see this word each or every or per, several, some clue words like that, it means that's the number that gets the variable. So $2.50 X. As you keep going through the story, it says he spent $7.50 for lunch. And he's not eating lunch multiple times. So that's going to be just plus $7.50. Last part, it says he spent less than. It doesn't say anything about equal to. Less than is a symbol that just looks like this. And that's it. How many times could he have ridden the subway? If I put these pieces of information together, I can work it out and solve it. $2.50 X plus the cost of lunch is less than $20. I'm going to draw my line down, this less than symbol, and then I'm going to start working backwards. The opposite of adding $7.50 for his lunch would be take away what he spent. And again, 20 is not a decimal, so I'm going to put 0.0. And I'm only going to put 0.75 because the 0 really doesn't matter. It's not going to change my answer. 20 minus $7.50. This is not going to work out, so I'm going to borrow. Then when I do that, I should get $12.50. I'll go ahead and put it back in there. That is supposed to be less than. I'm going to take the $2.50 and I'm going to move it down here. $2.50 X. And we've talked about before too, when you divide with a decimal, let's say I put it over here, $2.50 divided, oh, messed up. $2.50 divided into $12.50. However many digits are with the decimal over here on this side, we need to move this decimal to the end. So I'm going to repeat the same step on this side, just to go back over if you need help dividing with decimals. And then now I would just divide 250 into 1250. And that actually will go exactly 5 times. If I put a 5 up here, whoops. 5 times 0 is 0. 5 times 5 is 25. And 5 times 2 is 10. Plus this 2 extra would be 12. So now I can say X is less than 5. He would have to ride the subway less than 5 times. Remember that when you're solving inequalities, it's just like regular equations. You still just work backwards.